Now we're going to take everything that we've been learning about conversions and apply them to drug conversion problems. It's just going to be all the same as what we've been doing, except there's going to be a little bit more information given to you in the problem, like a dosage or a drug concentration. So let's go ahead and start with how we go to approach these problems. Many time ratios are given to you, and when a ratio is given to you, realize that it can be used as a conversion factor. Sometimes it says this to that or this in that. Anytime that a relationship is given to you, realize you can convert that relationship to a conversion factor that is a fraction with the number and the unit that goes with that number on one side and the other number and a unit that goes with it on the other side. And then flip that fraction as you need in order to get unit cancellation. In doing a drug conversion, it's really just the same as any other conversion. The only thing that you might have as a little helpful thing here is that you always start with your dosage. It gives you the right units when you finish if you start with your dosage. One thing that also will help you is look at what the question is asking for. Put the answer, the units that you need in the answer, on the right side of the page, your dosage on the left side of the page, and that might help you be able to think through how do I go from the dosage to the units I need to get the correct answer. In the text of your problem, you will often find that there are concentrations of medicines given to you, and you want to convert those into conversion factors. So if it says 100 milligrams per 2 milliliters, you know you can write a fraction that is 100 milligram over 2 milliliter, and you can flip that fraction as needed. You will also be using metric conversions, and an example would be going from microgram to milligram. And I know, just because I've been using micrograms and milligrams so much, there are 1,000 micrograms in 1 milligram. If you do not know that relationship, stick with the prefix method of going from one unit to another in the metric system. Now, in your dosage, you will often see a kilogram in the denominator, or it will say a particular amount per kilogram. That per kilogram, or sometimes it's per pound, means per mass of that person. So in your calculations, you have to eliminate that unit by multiplying by the mass of the person. Realize if the dosage is given in per kilograms and the mass of your person is given in pounds, you have to do a kilogram to pound conversion somewhere in that problem. Just make sure that your units cancel out. If you make sure your units cancel out, you'll be fine. Well, here's an example. It says, what is the amount of gallamycin that is needed for a 416 kilogram cow if the dosage is 12.5 milligrams per kilogram? The first thing we need to do is write down the dosage. And I want to emphasize this is not the only way to do a problem. You can do it other ways and get the right answer. But if you start with the dosage and write it as a fraction, if you need to, sometimes you don't have to write it as a fraction, but write your dosage first mathematically, and you will always end up with your units in the right place. If you start at another place, it is possible your units will end up upside down. So it's always the best to start with the dosage. You start with the dosage and think about what you want to get to. And the amount that you need is really just going to be the number of milligrams. So I look at these units and I say, milligrams per kilogram, I need to know how many milligrams only, so I have to get rid of kilogram. How do I get rid of kilogram? Well, I multiply by the mass of the cow, which is 416 kilograms. So I multiply by 416 kilograms. Notice, kilograms cancels out, and milligrams is what you end up with. You have 2.51 is in the numerator, 416 is in the numerator, so it's just 12.5 times 416, and it ends up giving you 520 milligrams, or you might want to express it as 5.2 grams. And since it says what amount and a unit is not specified, you can choose how to express it. If the question said how many grams, you would have to change it to grams. Read your question carefully and you'll know exactly what to do. So here's the problem. What is the amount of heparin that needs to be given to a 168-pound patient needing 150 units per kilogram? What do you always do? Start with the dosage. So think, what am I giving the patient? Well, I'm giving him 150 units per kilogram. So I write that down mathematically. Here it is mathematically. Remember, per means divided by, and there's the divided by. So now I need to get to the amount of heparin, so it's going to have to be in units. Don't let this unit scare you. That unit is an activity unit, and several drugs, insulin, heparin, a few others, they come as activity units because how active they are is not dependent on how many grams or milligrams or anything, but is dependent on how active the biologically derived drug is. So you have to, it's what they do is they make it and then they test it for activity and prepare it in a certain concentration to give you a certain number of units of activity. So this unit is just like any other unit that you would cancel out in, or you might want to get to in order to figure out the problem. So here it is. We're starting with the dosage. Now we want to figure out how many units to give this patient. So kilogram needs to be gotten rid of, but you have pounds for the patient. The first thing you need to do is either convert pounds to kilograms or convert kilograms to pound. I'd like to start with converting pound to kilogram, so kilogram to pound. So here's my fraction. Notice kilogram is in the denominator, so I put in the fraction kilogram in the numerator. Pound is then in the denominator. I need to make this fraction equal to 1, so I'll have to put a number in order to make it equal to 1. There are 2.21 pounds in a kilogram, so now my fraction is equal to 1. Next, I need to figure out how much to give this particular patient. I have the patient's mass in pounds, so if I multiply by the mass of the patient, now I see that kilograms cancels out, pounds cancels out, and all you have left over are units, which is what you would give the patient. And there we go, 1,100 units of heparin.
Go ahead and try this problem. If a patient should receive 100 milligrams of Lasix and the label states 40 milligrams per milliliter, how many milliliters should the patient be given? Pause the lecture and do this problem.
To do this problem, you must ask yourself, what am I giving the patient? You're giving your patient 100 milligrams, so that's what you start with. That is the dosage. So we have 100 milligrams written right here. So now what we need to do is convert that to milliliter. In the problem, you notice the concentration is given. There are 40 milligrams per 5 milliliters. This means I can convert milligrams to milliliters, which is what the question is asking for. So I'm going to go ahead and place a fraction in there that will convert milligrams to milliliter. Notice milligrams are canceling out, and we will end up with milliliter in the numerator. Now we have to make our fraction equal to 1. Notice 40 is with milligram and 5 is with milliliter. So those numbers need to be put into fraction, staying with the same units. I now can multiply through, and I get milliliters as the unit product, and then I get 12.5 as my number product. How do I get 12.5 on the calculator? Well, 100 is in the numerator, so I just enter 100 in the calculator as it is. 5 is in the numerator, so it's times 5. 40 is in the denominator, so it's divided by 40. You should end up with 12.5 on your calculator. Here's another problem. So again, you ask yourself, what am I giving the patient? And that is 0.11 grams of Voltaren. So that's what you will want to do, is put the 0.11 grams down. Now it says twice each day. The problem is, how many tablets should the patient be given? You don't ever give the patients everything you're going to get in one day. So you're not going to ever calculate what you give someone in the entire day unless you're only giving it to them once a day. So what you're going to have to do is just figure out how much to give them for one of those particular times. So it's 0.11 grams is the dosage, and you're wanting to go to tablets. If you look at this, it tells you that there's 50 milligrams in a tablet. So I know, I think in my head, and I look at this and I see gram, and I think, well, I can't go directly to tablet. I'm going to have to go gram to milligram and then to tablet. So the first thing I'm going to have to do is convert gram to milligram. So here is my gram to milligram, and then the next step I'm going to do is take milligram to tablet. And you can see there's the fraction for that. Notice grams cancels out, milligrams cancels out, and we end up with tablet. Now we just need to make sure that the fractions are equal to 1. We'll go and do milligram to gram, or gram to milligram first. A milli means 0.001, or 10 to the minus 3. So I put that value in with gram. And tablet is equal to 50 milligrams, so 50 goes with milligram under tablet. And so now my fractions are equal to 1, and I can figure out the answers to the problem. Notice when you figure this problem out, you actually get 2.2 tablets, but it's impossible to give a patient 0.2 tablets, so you round it off to 2.
Don't forget to do the remaining problems at the end of the chapter, and make sure that you've done all of the in-text problems as you read. There are worksheets that include drug conversion problems and online quizzes that cover all the material in the chapter. Be sure and come for help if you're having any trouble at all.